Hello student, welcome back to another video section of data communication and computer network. On the previous section, we learned about the pool and selection protocol system. Today's section is all about bit and byte oriented protocol system. So let's start with this particular section in a proper note. First of all, I do know that whenever a particular layer is communicate with other layer in OSI model or any other data model, it is basically based on framing. So framing is a data link layer function whereby the packets from the network layer are encapsulated into frames. So every individual message which is passed from one layer to another layer must be consisting of packets, and every individual packet must encapsulated into the subsequent frames. The frames which is normally communicate from one layer to another layer over a network to communicate its task. So the data frames can be fixed length or variable length. So it depends upon how much data can be communicated or can be transmitted or can be transferred from one layer to another layer. So in the variable length framing, the size of each frame to be transmitted may be different. So in that particular, as you know that the data frames, the data is normally like whenever the data is transmit or transfer over a particular network, it is normally consisting of packets, and every individual packet having certain particularly frames. So in the variable length framing, the size of the each frame to be translated may be different. It means every individual frame in a synchronized mode or in a sequential mode must having its variable length or variable size. So the pattern of bits is used as a delimiter to mark the end of one frame and the beginning of the next frame. So there is a pattern of delimiter mark which is normally distinguish the frame 1 to frame 2 or to the frame n. So there are two types of variable size frames basically available in data link layer function. That is called, the first one is called character oriented framing and the second one is basically called bit oriented framing. So in this case, the section is all about bit and byte framing. So that's why your character oriented framing, also known as the byte oriented framing, and the second one is basically called bit oriented framing. So let's begin with the first next particular slide. In the physical layer, data transmission involves synchronized transmission of bits. As you know that every individual data which is transmitted over a subsequent network or over a particular layer is consisting of binary bits, that is zeros and ones, as I say earlier in the like pool and selection protocol system. So basically it is normally the bit of particular bit is normally transmitting from source to destination, and that is called the endpoints. The data link layer packs these particular bits into frames. So every individual particular bits, like in the previous section, we learn about 8 bits of data or 8 bit normally into a subsequent frame. So every individual frame must contain at least 8 bits of binary, that is zeros or one, any combination. So the data link layer takes the packets from the network layer and encapsulated. It normally hides them into or converts them into the subsequent frames. So the basically data link layer, the responsibility of the or the task of the data link layer, it normally encapsulate the subsequent packet from the network layer into converting into the subsequent frame. If the frame size become too large, then the packet may be divided into small size frames. So as you know that arbitrary length particular messages whenever transmit or whenever transfer from one layer to another layer over a network, that is depends upon its size. So that's why if the particular frame size become too large, or you can say normally is lengthy particularly, so it can be converting into, or it can be divided into small size frames. So each and every small size frame easily communicate or easily transmit over a network without any traffic. So the smaller size frames makes a flow control and as well as error control more efficient. As I said earlier, in basically like the network layer or any other layer, it normally communicate or it normally transmit the subsequent particularly data frames and over a particular network. Before that, it must actually control the flow or the flow control and as well as checking for the error itself. Then it sends each frame bit by bit, that is 0 and 1 combination bit by bit on the particular hardware. So as you know that basically there are certain particularly n points there like source and destination. In between there are certain components that is called the hardware component, which are widely implemented for like communicating or transmitting the subsequent particularly frames or packets from one direction to another direction. At the receiver end, the data link here picks up the signals from the hardware and assembles them into frames. So basically, there are different type of protocols can be like communicate here to achieve their particular task. It means like in TCP/IP protocol, that is transmission control protocol. It normally first of all on the transmitter end, it divide the subsequent particularly message or information into small packets or into small sized packets, and over a network, it can communicate from source to or transmitter end to receiver end. After all the subsequent small packets or small size packet received in the receiving end, after that it can reassemble the subsequent thing to build a subsequent message through which the user can easily understand the subsequent message. So this is basically called the part of the frame, and the part of the frame is consisting of basically four subsequent particularly terms or four particular like four particularly parts. The first one is called frame header. So over a communication over a communication network, it must having the subsequence particularly the frame or the parts of the frame or the frame having a like a sequential of particularly like terms. Like the frame header, it contains the source and destination address of the frame. As I said earlier, whenever a particularly information or message or packet normally communicate over a network, it must contain the source and as well as the destination address. It means who sends and who receives, that should be available with the subsequent particularly frame. So it normally the frame header, it is normally called the header. It contains the source and destination address of the subsequent frame. And the second one is called payload fields. It normally contains the message to be delivered. So actually the message is normally consisting or available within this part, that is normally called the payload field. And the third one is called the trailer. Like obviously every individual like you can say content having a header part and as well as a footer part. The trailer is nothing, it contains the error detection and error correction bits, because flow control, error control, all subsequent things can be done by the subsequent layer. That's why the trailer, it contains the error detection. If the subsequent message is having any error, so after that it can check for the error and detect. After detection, it normally correct the subsequent particular error over it on the base of the subsequent field. So that's why every individual layer must supply the secure or highly valuable data from one layer to another layer. And the last one is basically called flag. And flag, it makes the beginning and as well as the end of the frame. So the flag is normally called an 8-bit particular like frame. So it normally in the beginning and as well as the end of the subsequent particular frame. So every individual frame must contain the end, the start and as well as end having the flag, and after that the header, and the header contains, as I say earlier, the source and destination address of the subsequent frame, and the payload field is normally contain the subsequent particular message which is normally delivered from one end to another end, and after that again the trailer having the error detection and error correction particular bits, and again the last one again ends with the flag system itself. So next is the types of framing. As I say earlier, there are two types of framing there. Like one is called fixed size, another thing is called variable size. So framing can be basically two types. So the first of all, the fixed size frames. Here the size of the frame is fixed, means every individual frame having equal length, and so the frame length acts as a delimiter of the subsequent frame. So it normally indicates, because each and every frame in the fixed size framing having equal length or equal size length. So that's why basically the frame length here acts as a delimiter of the subsequent frame. So it is normally in a consecutive or consecutive mode. So it does not require additional boundary bits to identify the start and as well as the end of the frame. So it is normally fixed in size. So there is no need of no requirement of the starting and as well as the ending frame. So for example, your ATM cells. So every individual particular cell having equal value or equal length. And the second one is basically in this case, that is called variable size framing. Here this particular size of here the size of each frame is transmitted may be different. So the first frame may be one length, the second frame may be more than one or less than one, the first length, and similarly up to the nth length. So the additional mechanism are kept to mark the end of one frame and beginning of the next frame. So here it must require a mark of the delimiter mark must be the first, means the end of the each frame, one frame, and as well as the beginning of the next frame. So it is used in local area network concept. So widely there are basically two types of framings there. One thing is called your fixed size, the size of the particularly or the length of the subsequent frame is different from one particular frame to another frame. But in the case of variable size framing, it normally each and every frame having the you can say the varies. So this is basically called the example or the diagram of, this is called the fixed size framing and this is called the variable size framing. In this case, the very first is the fixed size framing. It normally contains F1, F2, F3, that is 3 frames. So every individual frame having equal size. So in this case, so every individual frame having equal size, so there is no need of any delimiter or delimiter marks in this case. So it acts, the frame size is normally acts as a delimiter mark. So on the other side, the variable size framing is every individual. There are 3 frames, there are F1, F2, F3. So F1 is normally more lengthy or more bigger size or larger size than F2 and as well as F3. So in this case, the delimiter mark must be required over a network, because by the help of the delimiter mark, the receiver end should understand what type of frame concept is that. So for using, basically there are 2 approaches used for the variable size framing, because in this case there are fixed size and variable size. So variable size framing, for variable size framing, there are 2 approaches or there are 2 subsequent particularly methods can be widely implemented. So the framing is a particular data link layer function whereby the packets from the network layer are encapsulated into the subsequent particularly frames. So in this case, again I am repeating the subsequent slides. There are variable length and character oriented, or you can say character oriented framing and bit oriented framing. So next is normally called what is character oriented or byte oriented framing. So in a character oriented protocol, data to be carried are 8-bit character. That is basically, you know that one character is equivalent to 1 byte is equivalent to 8 bits from the coding system such as ASCII, that is called American Standard Code for Information Interchange. So in this case, or the character oriented or byte oriented protocol, the data to be carried 8 bits of particular characters, means the character is normally converting into binary bits, that is consisting of zeros and ones or strings of zeros and ones of 8. So the header, which particularly normally carries the source and destination address and other control information, and the trailer, which carries the error detection or error correction redundant bits like the duplicate bits, are also multiples of particular 8 bits. As I said earlier, there are 4 subsequent particular parts there, like flag, like you can say playoff, then header and trailer. So the header is normally consisting of the source and destination address, and normally the trailer also contain the error detection and as well as the error correction. So to separate one frame from the next, an 8-bit, that is 1 byte flag, is added at the beginning and at the end of the frame. As I say earlier, every individual frame in any particularly oriented like bit or byte oriented protocol normally contains the flag. It is normally in the beginning and as well as the end. And the beginning flag or the end flag normally contain 8 bits of particularly like data. That is normally, that's why in this case to separate one frame from the next frame, an 8-bit, that is 1 byte flag, is added at the beginning and as well as the end of the frame. The flag composed of protocol dependent special characters signals the start or end of the frame. So it is normally called, the flag is called composed of protocol dependent signal characters. So it must be the subsequent 8 bits of information. So in this case, the byte oriented protocol, the frame and packets are interpreted as a series of bytes. So it is normally like interpret on the base of like the bytes, that is called 1 byte or 8 bits. So it means while the message is present inside the frame and packet in byte form is known as byte oriented protocol. So every individual, like you can say the byte oriented protocol, the frame and as well as packets are interpreted as a series of bytes. So that's why it is a code dependent, like in that separate code, that is either like ASCII or EBCDIC, that specify code that either it is EBCDIC or ASCII format to detect the interpretation of the subsequent particular control bit field. So it is purely based on, like we can say, the ASCII and as well as subsequently EBCDIC code. And you know that BCD code is there, EBCDIC code is there, like ASCII code is there. It is all subsequent codes are interrelated with the byte oriented, that is called character oriented protocols. This is basically a simple diagram of byte oriented protocol. The first of all, it contains flag. It normally holds the 8-bit of information, and the next is normally called the header, which contain the source and destination address of the subsequent nodes. And third is normally called, this particular thing is called variable number of characters, or that is normally called from the upper layer, that is normally called the players, or it normally contains subsequent particularly binary bits. And trailer also contain the error control and as well as error detection, and last again it contains the flag. So in character oriented framing, like the character oriented framing was popular when only text was exchanged by the data link layer. So it is purely based on text oriented concept. It does not actually support the graphs, the complete graphs of something. That's why the flag could be selected to be any character not used for the text communication. So the subsequent flag is completely rely on the text oriented things, that is called the text particularly information or the text data, which is normally exchanged over the subsequent layer. However, we particularly send other type of information such as graphs, audio and video. So it is also support somehow like the graphs and as well as audios and videos, means it also support the multimedia components. Any pattern used for the flag could also be part of the subsequent information. So it also, because it depends upon the flag, because the flag is normally first reached in the transmission end, because every individual particularly frame having a flag in the beginning and as well as the end. So next is called the bit-oriented protocol. The bit-oriented protocol, the data section of the frame is sequence of bits. As I said earlier, it is normally containing zeros and ones, that is called the bit sequence of bits to be interpreted by the upper layer as text, graphics, audio, video, and as well as so. Here one simple example. Basically in computer system there are two type of file systems there. One is called binary file, another thing is called text file. Text file is purely like you can say the notepad related files, that is completely based on the ASCII value. And the binary file is normally contains like your graphics, audio, video, and as well as other particularly related data which normally kept inside a particular file. So in this case, the bit-oriented protocol, the data section of the frame is a sequence of bits to be interpreted, because it can be interpreted over the subsequent network by the upper layer. So as a particular text, graphics, audio, video, and as well as so on. It means any type of particularly data can be interpreted over the subsequent network by the upper layer to be transmitted. In addition, the headers also particularly like you can say as well as the trailers, we need a delimiter to separate one frame from the other particular. So here in this case, because every individual after 0 and 0 and 1s of communication or 0s and 1s of bits in a subsequent frame, it must require a separator or a delimiter mark to separate from one particular frame to another frame. So most protocols use a special 8-bit pattern flag, that is in this case 0 then followed by 6 1 and followed by 0 as the delimiter to define the beginning and as well as end of the frame. So most of particularly like protocols, most protocol in the subsequent particular layer normally depends upon the 8-bit pattern, that is for the flag. So the flag normally contains the first 0 then followed by 1 1 1 1 1 1, that is 6 1 then followed by 0 as the delimiter, because it is for the delimiter mark for the subsequent flag from starting and as well as ending. So bit-oriented protocol are suited for transmitting any sequence. It can actually transmit any sequence of bits. So it may be like 1 followed by 6 0 followed by 1, or it may be 1 followed by like 4 0 then followed by like 1 1 1. Any type of bit sequence can be like transmitted over the network. So there are particular chances that the pattern of the flag bit is present in the subsequent spaces. So it must require the subsequent flag or the flag bit of pattern must be there in the subsequent frame, because every individual particularly frame normally does not contain the similar type of information, similar type of particularly data. So for that it must require, it is a simple particular diagram, so just check it out. First is the like flag that is in the yellow set, and again flag in the right side that is called the end, again the yellow set. So it normally contains 0 then 6 1 followed by 0. So after that it can contain the header part, as I say area. Header normally contains the source and destination address and followed by the variable number of bits, and it is basically called the data from the upper layer. So the upper layer is normally transmitting data to the subsequent particular layer over a particular bracket or framing concept. Then after that the trailer, again it contains the detection, the error detection and as well as the error correction subsequence particularly approaches, and last again it normally called contain a flag. So the flag again contains 0 then followed by 6 1 followed by 0. So the flag can create the same type of problem we saw in the bit-oriented protocol, because it must require the subsequent separator mark or the delimiter in between the subsequent frame, because whenever the frame is communicated over a particular transmission medium, so when the receiver receives that particular thing, it is little bit confused. So every individual bit after that there is a particularly marks there. Like simple अगर यहाँ पे हम लोग एग्जांपल बोलेंगे, अगर हम लोग मोर देन वन सेंटेंस लिख रहे हैं तो मोर देन वन सेंटेंस में अगर एक सेंटेंस कंप्लीट होने के बाद हम लोग एक पीरियड देते हैं या डॉट देते हैं, अगर हम लोग उस डॉट को मेंशन नहीं करेंगे तो जिसके पास वो पर्टिकुलर कंटेंट होगा या जो उसको रीड कर रहा है वो नॉनस्टॉप उसको कंटिन्यू करेगा, बिकॉज after completing of one sentence it must require a dot, that is called the like terminator of the subsequent sentence. Similarly in any programming language like in C, C++, it must require a semicolon. If the semicolon does not exist in the subsequent code, it normally makes certain error, so it is little bit confused. So that's why the flag can create the same type of problem as in particularly in the byte oriented protocol. That's why if flag pattern appears in the data, we need to somehow inform the receiver that this is not the end of the frame. So it is normally called that every individual flag must be there with the subsequent particularly frame, the data frames. So it is for the indication to the receiver, and the bit frame of the sequence of frame is not end. And basically in this case this is basically called the byte oriented protocol, like stopping and unstopping. The stopping and unstopping is nothing, insertion and as well as like remove or like you can say the deletion. So in this case just take it out. First is basically called, it is called the data from the upper layer, and this is basically called the frame, and the frame is normally contains, first is called the sending frame, flag, followed by header, then followed by subsequent particular data, and one escape character is required, then followed by flag, and followed by escape, then escape and trailer and flag. So in this case, basically, like you can say in the byte oriented protocol, say we are normally the byte oriented protocol. Basically, the frames maybe have a particular bit pattern between frames to help identify the start and as well as end of the frame. So as I say here, flag is there in the beginning and as well as the ending. So this kind of special bit pattern is therefore stood as a flag. So that's why basically in this like diagram, the problem is that the flag bit pattern could appear in the data portion of the frame because the starting having a flag, and again this particular flag is there, so it is normally in between the subsequence, particularly like data. So that's why this particular the problem is solved by stopping. So for that it must require stopping, that is called the insertion, a special bit pattern known as escape character. So ये एक ऐसा चीज है जैसे कि हम लोग अगर एक डेटा कंटिन्यूस वे में फ्लो कर रहे हैं, सीक्वेंस ऑफ डेटा फ्लो कर रहे हैं रिसीविंग एंड में, अगर आप लोग कोई डेलिमिटर मार्क अगर प्रोवाइड नहीं कर रहे हैं तो उस केस में क्या होगा, नॉर्मली रिसीवर समझ जाएगा, रिसीवर को समझ में आएगा कि यहाँ पे आपका नॉर्मली डेटा ओवर हो गया या डेटा कंप्लीट हो गया. फॉर दैट द particularly flag patterns or the flag bit patterns normally available in the subsequence, particularly portion of the frame, that is called the data portion of the frame. To subsequence means to overcome this particular problem, we are normally required insertion, that is for stopping, and a particularly stopping character or a particularly escape character should be the subsequence or should be stopped or should be inserted in a like data portion of the subsequence frame. So if a particular there are two subsequence escape characters there, so in this case the subsequence you can say the escape character should be there in the data pattern. And the next bit oriented protocol, in this case we just check it out. First of all, data from the upper layer, and it normally contains 0 0 0 1 1 1 and followed by 7 ones, then followed by 0 0 and followed by 3 5 1 and followed by 0 and 1 triple 0. So in this case it is basically whenever we stop that stop means inserted that thing. So every 5 consecutive 1 after मतलब after consecutive 1 जब होता है, जैसे कि in this particular data it is having continuously, that is 3 0 then followed by 7 ones. So after each 5 1 there is a stopping of 0, that is normally called 0 bit stopping. So by the help of that particular node the receiver can understand. So because every particularly 8 bit character in a subsequence framing or a pattern, so receiver को ये समझ में आ जाएगा that after particularly 7-8 bits there is a particularly 0 stop, that is called insertion. Then after that there are certain particularly data frames also there. So in this case every 5 consecutive 1, if a particularly bit pattern having consecutive 5 ones, अगर 5 मतलब continuously आपका 1 available है, then after that the 6 1 के बीच आपका basically एक 0 आ जाएगा. In this case there are 7 ones in the data, so that's why after 5 1 मतलब 5 1 के बाद एक 0 आपका add होगा, that is normally called the stop. So it is there with the subsequence particularly data bit pattern, and if we normally like remove that particular thing, it is basically called on stop. So basically it is like a standard communication or a standard particularly approach or mechanism for stopping and as well as on stopping of the subsequent bit patterns, through which we can easily like directed or easily like normally हम लोग उसको बता सकते हैं जैसे कि इसके बाद भी आपका continuously data है, because it is normally contains the sequence of particularly like bit patterns or bits. So there is a specific delimiter or the flag or the escape character. The escape character should be there in the byte oriented protocol, but in this case, that is bit oriented protocol, normally contain every individual 5 ones. After that it can add or it can insert or it can stop at 0 to the subsequent bit pattern, to which the receiver end easily understood after reading the subsequent particularly bit pattern, the continued bit particular sequence is there. Thank you. I hope so you go through this particularly video If any query, I can solve on my I can solve this particularly like those problems in my next query. Thank you.